Alright folks, in this class period, in this video, we are going to discuss graphing piecewise functions. Our goal is going to be to graph basic piecewise functions. So we have to first recall what to do about inequalities, recall substitution, and ordered pairs. Those are the three major skills. So is x equals -6 a solution to x is less than or equal to -6? Yes, because it's equal, so that's okay. However, is it less than -4? And the answer is yes again. Think about a number line. Okay? -6 is to the left of -4, so it's less than. For substitution, just like before, if I give you find f of 5, that's saying that x equals 5. I want us to plug that in. In this case, if I put 5 into f of x equals 3x minus 12, I get f of 5 equals 3 times 5 is 15, minus 12 is 3. And lastly is ordered pairs. Recognize that when I give you f of 5 and you calculate 3, that is the ordered pair 5, 3. So we're going to piece those ideas together today in this quick video to graph piecewise functions. When graphing piecewise functions, we want to look at two separate functions or equations. First, x minus 1. So we are going to actually graph y equals x minus 1. However, I'm only going to do that for x is less than 2, which means if I were looking at this on a number line, I would have a positive 2, open circle, and shade it to the left. That's important because the best way to graph these types of functions is using a table of values. And we have to identify x values and calculate y values. What x values do we pick? Always, always, always pick any x value that's in your inequality. I am going to always start with those, so I'm definitely picking 2 because it's in the inequality. What other x values do I pick? I only need one more. And it has to be a number that is a solution, one of these numbers. Any of them would work. To make your life a little bit easier, pick the one closest to 2. That works in this inequality. In this case, that would be 1. So I now have 2 ordered pairs that I'm going to graph. 2 comma something, whatever I calculate y to be, and 1 comma something, whatever I calculate y to be there. How do I calculate? I substitute these x's into this function. 2 minus 1 is 1. So when x is 2, y is 1. Or substitute 1 in, 1 minus 1 is 0. So when x is 1, y is 0. That's the first part of it. The second part of it is, what do I do now? Okay. And it's very similar to what we did here. X is 2 was an open circle, so when my x is 2 here, I'm going to graph an open circle at that ordered pair. 2, 1, open circle. But what do I do here? I don't stop. When I'm graphing this inequality on the number line, I don't stop. I keep going all the way through 1 and write an arrow at the end. I'm going to do the same thing here. I'm just going to plot this as an ordered pair. I'm going to start here, go through that ordered pair, and have an arrow. Now in this case I have it going to the right, but up on the actual coordinate plane, 1, 0 is here. So what I'm doing is not going in this direction here. I'm going to start at my 2, go through this point, and go forever, put an arrow. I've graphed the first piece of this piecewise function. The second piece is treated the same way. I am going to be taking a look at, and I'll just give myself space here, y equals -2x minus 4. I need values of x, check for values of y. What x's do I pick? Well, x has to be greater than or equal to 2, which on a number line would look like a closed circle here, shaded to the right. I have to pick 2 with this function. And then I need a second number, but it has to be accurate in this inequality, which means that I could choose 3 or 4 or 5 or 6 or anything. The next one to the right, the next one that makes sense, that is a solution, is 3. Go ahead and solve. If I substitute 2 in here, I get negative 2 times 2 minus 4. That's negative 4 minus 4. I get negative 8. When I substitute 3 in, I get negative 2 times 3 minus 4. I get negative 10. So I'm going to graph the ordered pairs 2, negative 8. And that's going to be, since the 2 on my number line would be a closed circle, this is a closed circle. 3, negative 10. Since that's a line that goes through this on my number line, I'm plotting that as a point. I will start at my 2 for x, go through my second point and put an arrow. 2, negative 8, plot the point. 3, negative 10, plot the point. Start at 2, go through this, and put an arrow. I'm done. I've graphed this first piece, I've graphed the second piece, they do not overlap. This passes the vertical line test. On our second problem on the next page, I have to graph y equals negative 3 as long as x is less than or equal to negative 4. Y equals negative x whenever x is bigger than negative 4. Again, the numbers in my inequality, so for negative 3, I have to use negative 4. I have to choose my second one. For y equals negative x, I have to use negative 4. And then I get to choose my second one. The choice I make goes along with my inequality. Negative 4, I could use negative 5, negative 6, negative 7, negative 8. Any of those numbers will do, as long as it is a solution to the inequality. I'll use negative 5. That's the easiest. It's the first one. The good news is, in this equation, negative 4, my y is negative 3. Because y is always negative 3. There is no x. This is not dependent on x. Negative 5, negative 3. This is a closed circle at negative 4, so my negative 4, negative 3 ordered pair is going to be a closed circle. And then I go forever to the left, or forever in the negative direction, forever through every other point. So another point would be negative 5, negative 3. I'm going to graph this forever through that point. Here, through this point, forever. For my next one, I've used negative 4. I need a second one. Well, I could use negative 3, negative 2, negative 1, 0, 1. It doesn't matter. Again, if I just want to make sure I'm using the easiest number, I'm going to use the next one. That is a solution, negative 3. Be careful with your negatives here. Negative x for these becomes the opposite of negative 4. That's positive 4. The opposite of negative 3 is positive 3. This is an open circle at negative 4, so negative 4 for x is going to be an open circle. Graph in the direction of negative 3, but it has an arrow on it. So at negative 3, 3, I'll plot the point. I'll go through that point and put an arrow. Negative 4, 4, open circle. Negative 3, 3, plot the point. Start, through, forever. In our last example, we have 3 sections, or 3 pieces. The first piece is just y equals 7. X is less than or equal to negative 2. So I definitely am using negative 2, and then I'll use negative 3, or negative 4, or negative 5. And this is another one of those constant functions. Y is 7. Y is 7. Doesn't depend on x. Closed circle, arrow. Negative 2, 7, closed circle. Negative 3, 7 means start, go through it, arrow. The next example is a little bit different, but it has 2 numbers in the inequality. That's even better. I don't get to choose a value of x. I have to use them both. I don't have a choice. Not only that, I recognize from the inequality symbols that at -2 I'm going to have a closed circle or an open circle. At +5 I'm going to have an open circle. I'm not going to have an arrow here. I just connect those two open circles in this case. Find y. Well, -2 plus 2 is 0, so open circle at -2, 0. 5 plus 2 is 7, open circle at 5, 7. Connect the dots. Don't go past them. Those are endpoints. I can only work between -5 or -2 and 5. On the last piece, it's back to having to pick an x. I have to use 5, that's in my inequality, but then I have to use something bigger than 5, so 6 or 7 or 8 or 9. In this case, I'll choose 6. It's the easiest. 2 times 5 minus 3 is 10 minus 3, or 7. That's my x equals 5. That's a closed circle. The other end is an arrow, so I'm going to go through whatever point this is with an arrow. 5, 7. If this happens, I just get to fill that in. This is going to be trickier if I was analyzing the graph, but for now, that's not a big deal. 2 times 6 minus 3 is 12 minus 3, which is 9. I graph the point 6, 9, through that point with an arrow. We're going to do a lot of examples of these in the next couple of days. Come prepared to ask lots of questions.